The atomic bomb. A triumph in the sense that scientific and technological advances have strived so far, yet a tragedy in the sense that the purpose for these bombs are to kill.
Atomic bombs must have a fissile element, usually that being uranium. Most atomic bombs use uranium-235, or more commonly known as U-235, as they can sustain the process of nuclear fission. When a U-235 atom is split by a neutron, an immense amount of energy is created. This later continues in a chain reaction with each new atom being split.
The energy created by the nuclear fission is immense and could act as a great power source in the near future. Many people will say that the main triumph of the atomic bomb was the scientific achievement itself. However, we believe that it may prove as a solution to saving finite resources instead of using them for energy. The history of the atomic bomb. 1789, uranium was discovered by Martin Klaproth, a German chemist.
1895. Ionizing radiation was discovered by Wilhelm Röntgen by passing an electric current through a glass tube to produce continuous X-rays. 1896. Henry Becquerel found an ore containing radium and uranium that, being pitchblende due to beta radiation, electrons, and alpha particles, helium nuclei, being emitted, Paul Ulrich Villard had found a third type of radiation from pitchblende, gamma rays.
1902. Ernest Rutherford showed that radioactivity as a spontaneous event emitting an alpha or beta particle from the nucleus created a different element. 1919. Ernest Rutherford fired alpha particles from a radium source into nitrogen and found that nuclear rearrangement was occurring with the formation of oxygen.
1932. James Chadwick discovered the neutron. Cockcroft and Walton produced nuclear transformations by shooting accelerated protons into atoms. 1934. Irene Curie and Frederick Joliot found that some such transformations created artificial radionuclides.
1935 to 1938. This period of time was of extreme significance due to the research conducted by Enrico Fermi. He found out when neutrons instead of protons were used, a wider variety of radionuclides were to be formed. Later, Fermi realized through even further investigation that using uranium-235 produced lighter elements as well as heavy elements.
1938. Otto Hahn and Fritz Strassmann in Berlin showed that the new lighter elements were barium and other which were about half the mass of uranium, thereby demonstrating that atomic fission had occurred. Lise Meitner and her nephew Otto Frisch, working under Niels Bohr, then explained this by suggesting that the neutron was captured by the nucleus, causing severe vibration leading to the nucleus splitting into two not quite equal parts. 1939. Hahn and Strassmann were the most significant figures of 1939. They proved that fission not only released a huge amount of energy, but that it also released additional neutrons, which could cause fission in other uranium nuclei.
We do know it is equivalent to mass. Therefore, we may speak of it as having a kind of weight of its own. Now, the two atoms into which a uranium atom splits also have binding force. But for some reason, it takes less of that glue to hold them together, and in the process of fission, a tiny fraction is left over. What happens to it? It explodes as energy.
This meant that a self-sustaining chain reaction leading to an enormous release of energy had finally been proven by the two men, Hahn and Strassmann. Bohr proposed how using uranium-235 isotope, then uranium-238 isotope, would cause a fission occurrence more effectively with slow-moving neutrons than with fast-moving neutrons. This allowed for even greater energy releases.
The triumph. How much energy can atomic bombs create? The world has witnessed the bombings of Hiroshima and Nagasaki, which resulted to over 130,000 deaths. The energy emitted from the little boy bomb which was used in Hiroshima was between 12 and 18 kilotons of TNT, or 50 and 75 terajoules. The energy emitted from the Fat Man bomb, which was used in Nagasaki, was between 18 and 23 kilotons of TNT, or 75 and 96 terajoules. At minimum bounding, 50 terajoules and 75 terajoules, an equal of 34,722,222.25 kilowatt-hour, is evident. An average home in the United States consumes 10,900 kilowatt-hour per year. That is enough energy to power 3,185 average electricity consuming homes in the United States for an entire year. Nowadays, atomic and nuclear fission and fusion have advanced so far, meaning that scientists can create more efficient ways of energy production on larger scales. This is seen in nuclear power plants. The problem is, nuclear power plants can face meltdowns, such as the ones seen previously in Fukushima, Chernobyl, and 3 Mile Island.
Recently, an American nuclear physics enthusiast, Taylor Wilson, had tried to bring an old solution into light by modifying the process to become more sustainable. This solution is MSBR, or Molten Salt Breeder Reactor, except that the reactor is deep underground. This is a realistic triumph, as in his TED Talk from 2013, he states that this nuclear reactor can last up to 30 years without maintenance. Furthermore, due to it being placed deep underground, it is able to contain radioactive content without the risk of leaking radioactivity or going through a nuclear meltdown.
The tragedy.
The only atomic bombs to be used in warfare, the Little Boy and Fat Man, caused over 130,000 deaths, many of those people being innocent. The tragedy is the simple fact that this nuclear science was and/or is being used for weaponry to kill. Already, a staggering number of 8 countries have declared possession of nuclear weaponry. These countries include the United States of America, Russia, the United Kingdom, France, China, India, Pakistan, and North Korea. Furthermore, Israel is under heavy suspicion of having nuclear weaponry, following a suspected test near the Prince Edward Islands. This is known as the Vela Incident, or also known as the South Atlantic Flash. Moreover, South Africa, Belarus, Kazakhstan, and Ukraine at one point all had nuclear weaponry, getting rid of them only due to the Nuclear Non-Proliferation Treaty. For now, these are only countries of which are known for or suspected of having nuclear weaponry. Consequently, this raises a question. Are there any other countries who have this destructive power? If a World War III breaks out, how will the Earth endure the nuclear destruction, and who will be the ones to stop it? At this point, entire existence itself of nuclear fission and fusion science poses as a threat because of how it can be weaponized. The weaponization, thus, is the ultimate tragedy.
Will the research of the atomic bomb be used for even more weaponry, or this time as an efficient go-green, non-harmful energy source? Although the science in nuclear fission and fusion has advanced so far, different people could use this power with malicious intent rather than with a mindset to save the future world. It can be argued that the world will by far be a quote-unquote better place without nuclear science. However, nuclear science could very much be the solution to an energy hunger, as fossil fuels will run out soon. Nuclear power plants supply 75.2% of France's energy, while it supplies 20% of the United States' energy. Countries like China have only 1.9% of their energy coming from nuclear power plants, as they heavily depend on the Three Gorges Dam and coal energy production. Following the steps of France's energy plan and solution, it is safe to say that the world will definitely lead to a more sustainable energy producing industry.
A conclusion has sort of been reached, evident with the Non-Proliferation Treaty of nuclear weaponry. The aim of this treaty is to prevent the spread and production of nuclear weaponry whilst achieving advances in nuclear fission and fusion science for a future energy solution. Although many countries have signed to this, it is our trust in these countries to abide by their said commitment. It is still very possible that a World War III could break out, and those with the nuclear weapons could destroy the Earth. What would be the point of advancing nuclear fission and fusion science for energy if there is no world to supply?